Okay, let's go over these problems. So, all three of these are problems that we should have been able to do in chapter 1 when we talked first about vertical angles and we talked first about um, supplementary angles. So let's go over problem number 1 and number 2. They're vertical angles problems. When you've got two angles that are vertical, you can just set them equal. So for number 1, we've got 2x plus 21 had better be equal to 4x. Well, let me solve for x, right? So we get 21 equals 2x. And then when I divide both sides by 2, I get x equals, you could either write it as 21 over 2, 21 halves, or you could also say 10 and 1 half, 10.5. Either of those writings of a problem like this for number 1 should be good. All right, so for number 2, same idea. They're vertical angles, so we just set them equal to each other. 3x equals 2x plus 40. Let me solve for x. I'm going to take the 2x and I'm going to subtract it over. That leaves me with x on one side and 40 on the other. Okay? Now with this third problem, the way that it's set up, you've got to find an x and you've got to find a y, right? Now, I'm not going to tell you that there's only one way to do this because there's not. You know, there's plenty of ways that you can do this. But to me, the easiest thing to do first is find y. Because remember, these two add up to 180, right? Well, what plus 76 equals 180? Well, let me subtract. Isn't this 104? So y is 104. And then if I want to find x, I have a bunch of options, but I think the easiest option is just to do the vertical angle one, set these two equal to each other. And then just solve for x. Right, 38. And the thing of it is, you know, as you're going through and doing these, there's going to be a lot of different ways to go about doing this. Some people might want to, they find that this is 104 and they say 2x plus 104 equals 180. Should you still get the answer of 38 for x? You should. So if I do it this way, I better get the same answer as I did up here, right? So let's make sure. I subtract the 104. And look what I get. 76, right? Well, isn't that what I had up here? So I know that this is going to be x equals 38. So I know it's got to be the same. So as you're going through and doing these problems, you're going to see a bunch of these on your homework, along with the stuff we're about to do. Don't overthink them. Take your time with them. Alrighty, let's go forward. So what are we going to be doing today? We're going to be talking about more. We're going to be talking more about vertical angles and complementary angles and supplementary angles, and using those pairs to not only solve problems like what we just did in the bell ringer, but also to prove things. We're going to be doing a little bit more in the way of proofs today, just showing some tools that we can use later on. And we're going to use a lot of like what we did on Wednesday to do the same sort of stuff. Remember back when we first introduced the concept of a vertical angle, I said, we're going to treat this as gospel for a little while. We're going to just say, hey, two angles are opposite each other on a cross like that. They're the same. Now we're going to show why. So this is what we have. This is called the vertical angles theorem. And the vertical angles theorem says that vertical angles are congruent, just like we talked about before. The opposite angles, if you notice, the north-south angles, 2 and 4 here, the east-west angles, 1 and 3, they're the same color, they look to be the same size, and we're going to show exactly why they have to be the same size. Why angle 1 has to be the same as angle 3, why angle 2 has to be the same as angle 4. Okay? And it doesn't matter how these two lines cross, it'll always be true. They could cross like this, or they could cross like this, or they could, even thinner than what they have here. As long as you've got a pair of lines, two lines, the opposite angles are going to be the same as each other. Now, if you have more lines that happen to be concurrent, like I don't know, like they make a third one in here, now you've got 3 pairs of vertical angles. These two are the same. These are the same. And then these are the same. So 1 and 2 are the same. 3 and 4 are the same. 5 and 6 are the same here. And you'll see a problem or two like that in your homework. It's just, make sure you've got the opposite pizza slices. They're the same as each other. So what we're going to do is we're going to go over why these things are true. And this first one and the next one, I'm going to just sort of show you, because I think it's important you see sort of the model for how these work. And I'm going to tell you all the ones that we're doing today are grouped together on purpose, just like all the ones from Wednesday were grouped together. All the proofs were very similar. All the proofs had the same kind of flow to them. They all had the same sort of techniques. Same thing here. Each and every one of the proofs that we're doing today follows the same sort of general guideline. Hey, here's two angles. They add up to a certain amount. Oh, wait, these other two angles add up to the same amount as the first two. Let's take those expressions and glue them together. And now we can get rid of all the extra that we don't need and come up with our answer. So look, what we know is that angle 1 and angle 3 are vertical angles. That's our given statement. Now, if you look up here, what do you notice about angle 1 and angle 2? Don't they add up to 180? Right? You see they make a straight line together? I can say the measure of angle 1 plus the measure of angle 2 equals 180. And how do we know that that's true? Well, what type of angle pair is this? Isn't this a linear pair? So remember we talked before about this is the definition of what a linear pair is, right? And isn't the same thing true about angle 2 and angle 3? These two also add up to 180. For the same reason. Now that we've done that, look, angle 1 and angle 2 add up to 180. Angle 2 and angle 3 add up to 180. So why don't we just set those two equal to each other, because they both equal the same thing, right? They both add up to 180, which means that they're the same as each other. So let's do that. Let's say Angle 1 and angle 2, the measure of angle 1 plus the measure of angle 2, better add up to the same thing that the measure of angle 2 plus the measure of angle 3 does. And why is this the way it is? Well, if A equals B and B equals C, then A equals C, right? This is what we call the transitive property. And in the book or on the homework, if you were to do this, they would specifically make you choose the one that says of equality, right? Not of congruence, because we're not dealing with congruence, we're dealing with equality. So now that we know this, what we want is we want that the measure of that we want angle 1 is congruent to angle 3, right? Well, what's standing in our way from saying something like that? Isn't it this angle 2 that's in here? So let's get rid of that angle 2. Let's subtract angle 2 from both sides. So by the subtraction property, we know that the measure of angle 1 equals the measure of angle 3. Again, all I did is I subtracted the measure of angle 2 from both sides, right? So since I know that the measure of angle 1 equals the measure of angle 3, can't I just switch that from equals to congruence? Yeah. So this last step, and I don't need this one anymore, which is great. Our last step is just that this is true. And why is it true? Well, if they're equal, then they're congruent. That's what it means to be congruent. That's the definition of congruence. That's what it means to be congruent. So now let's go back. Did I show all of my steps? Yeah. Did I give a reason for each step? Yeah. So am I done? I sure am. Let me put my little dingbat here at the bottom. And again, I make the little solid square box just because that's the way I was raised to do it. But if you want to do something else, you can. But make sure that your dingbat is at the bottom too. So this is why vertical angles are congruent. It's not just about the fact that I told you that they are. I mean, I did earlier, but now not only have I told you that it's true, I have backed up my assertion with proof, right? Not only did I tell you that it's true, but I showed you that it's true. I was given the fact that these are vertical angles, and then using this picture and using logic, I went through and step by step proved to you that it's true. So let's continue on. I'm going to do one more, and then you're going to give it a try. What I've got is that angle 1 is congruent to angle 4. That was given to me. So now we have this nice pretty tool about vertical angles being congruent. Let's use it. Since I know that vertical angles are congruent, what can I say? Well, I know that angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4. For the same reason, right? Well, now, wait a minute. Hold on. Suddenly, I've got this whole big chain of angles that are congruent to each other that I can link together. My goal is to link together 2 and 3 and show that they're congruent. Let's see if I can do it. 1 is congruent to 4. Well, what's 1 also congruent to? It's also congruent to 3, right? What's 4 also congruent to? 4 is also congruent to 2. Okay, so here's the thing. 3 and 2 are connected. I connected them, right? There's this chain, right? Right? And I've got all these things together that tell me that this is true. So I'm good to link all these together. So now all I have to do with what I have is make connections. So look, the transitive property allows me to say that I can skip one guy, right? I know that angle 3 is congruent to angle 1. I know that angle 1 is congruent to angle 4. That's these first two, right? So what I can say is I can skip straight from 3 to 4 and get rid of 1 now, right? So step 4, by the transitive property, of congruence, I can say that angle 3 is congruent to angle 4. I put the train together. Now I'm allowed to leapfrog over 1 and get to 4. And what does that leave me with? Now I've got 3 is congruent to 4, which is congruent to 2. So now I can use the transitive property again and play leapfrog once more. I can say, all right, well, now I can leapfrog 3 and go to 2, right? So let me do that. Using the transitive property again, I can now say that angle 3 is congruent to angle 2. They have it written that way, so I'm going to say angle 2 is congruent to angle 3. It doesn't matter the order. If you've got it backwards, you can always use the symmetric property to flip them, right? Actually, you know what? Let's model that because I want to make sure that y'all can see all the things that the world has to offer. Because based on the way I wrote this, I want to make sure that I'm following logic. And so we want this. So we can take one more step to say angle 2 is congruent to angle 3 by the symmetric property. That's one too many little symmetric property of congruence. And again, this is what I want. Now, look, here's what we did. We started out with this given information and this picture. The picture allowed to use our vertical angles theorem to show that angle 1 was congruent to angle 3 and angle 2 is congruent to angle 4. And now, seeing that they're all sort of connected, I made myself a little train so that I can use the transitive property. And the transitive property allowed me to leapfrog one guy, get rid of this angle 1. It's no longer needed. I don't need it for the final answer. And then I wrote that down. I can go straight from 3 to 4 now. And then I use the leapfrog again to use the transitive property to get rid of angle 4, the other one we don't care about, to leave us with angle 3 is congruent to angle 2. And then I said, all right, well, I don't want it to look like that. I want it to look like this. What allows me to flip it around? The symmetric property. And there we go. So I showed all my work. I gave all my reasons. I know I'm done now. Gonna make my little square box at the bottom. And then I'm good. All right, let's go ahead. See if you can think through the statements and the reasons. Think through the steps and see if you can show your work. Okay, so let's talk this through. We always make our given statement the first step. Angle 1 is congruent to angle 2. Why? Because they gave it to us. So we already know that angle 1 is congruent to angle 2. Now I want to somehow connect on angle 3. I'm not going to tell you there's only one way to do this. There's a lot of different ways that you could do this. There's a lot of different options that you have. But I'm going to tell you, if you look, angle 1 is congruent to angle 3 by vertical angles. And now look, angle 3 is congruent to angle 1, and angle 1 is congruent to angle 2. So let me make my little train car. Right? I've got this train car now. I don't need angle 1 anymore. I can use the transitive property to skip over and it's congruence because these are congruent. And now, once again, hey, look, I think I've got what I want. It's just backwards. Well, that just means I can use the symmetric property. And that's what I wanted to prove. That's what I wrote down. I've got all my work. I've got all my reasons given. So I can just say, hey, I'm done now. All right, I think I've got just a couple more. So I wanted to show you this one. This is called the congruent supplements theorem. Basically, this one says if angle 1 and angle 3 are supplementary, and angle 2 and angle 3 are supplementary, then angle 1 and angle 2 are the same. If two angles, to say it a different way, if two angles are supplementary to the same angle, then the two angles are congruent to each other. So let's do that. I've got a couple different statements that are given. I'm going to write them out separately. Angle 1 and angle 3 are supplementary. Angle 2 and angle 3 are supplementary. So if you'll notice, this is the exact same situation I was in over here, right? I know that I've got two pairs of angles that add up to 180. So don't they add up to each other the same way? So can't I just say, by the transitive property, the measure of angle 1 plus the measure of angle 3 equals the measure of angle 2 plus the measure of angle 3. And this is equal, so it's equality. Right? Well, now wait a minute. They both share that angle 3. Can't I just subtract that away? So let me use the subtraction. property. Subtract angle 3, what am I left with? The measure of angle 1 equals the measure of angle 2. This looks super duper familiar, doesn't it? Well, then how do I get from the measure of angle 1 equals the measure of angle 2 to them being congruent? Can't I just say that that's true because that's what congruent means? That's the definition of congruence. Wasn't that what I wanted? Isn't that what I have? I showed all my work. I gave a reason for each step. So I know I'm good. So the next one I'm going to show you, so we did the congruent supplements theorem. This next one is called the congruent complements theorem. Literally the exact same thing. The only difference is there's one word exchanged. Anywhere you see the word supplement in this, they're going to exchange it with the word complement. So that is to say, all this is telling you is that if two angles are complementary to the same angle, now they must be the same. So it's the exact same problem, pretty much. The only difference is now they have complementary instead of supplementary, right? See if you can sort of noodle through in your mind how to get through this. And I think it's really important to look at this previous problem and say, oh, it's literally the exact same problem, except for this one little thing, right? That's what makes this so great, is that you're basically doing the exact same thing every single time, and it's giving you basically a new problem, but just by changing one little word. And it's so great. Okay, so since hopefully by now the cat's sort of out of the bag, literally we're going to follow this exact same thing. The only difference is going to be because complement means they add up to 90 instead of supplement, which means they add up to 180. Literally, I'm just going to take this exact thing and I'm going to replace 180 with 90. Pretty much. I think maybe they changed around the way that the angles are numbered, and so that's slightly different too, but that's not important. This part's important. Here they add up to 180. Here they're going to add up to 90. So let's do the exact same thing. Angle 1 and angle 2, the measure of angle 1 plus the measure of angle 2 equals 90, because that's what they told us, that the complements. Statement number 2 will say the other one, the measure of angle 2 plus the measure of angle 3 is 90. Again, that's given to us because they say that they're complementary. So now, again, same thing using that transitive property, right? Angle 1 and angle 2 add up to the same thing as angle 2 and angle 3. And again, notice in the last one, I think they had angle 1 and angle 2, and then, or angle 1 and angle 3, and then angle 2 and angle 3. But see, it doesn't matter. We still have a pair of angles that we can subtract that'll leave us with the thing that we wanted, right? So I'm going to use the subtraction property. To subtract the measure of angle 2. Because I subtracted angle 2. And now they're equal. And whenever you've got two angles that have equal measures, you know that those angles are congruent. That's just a definition of congruence. And that's what we wanted. You know, again, if you look back and forth with these, you see how it's literally exactly the same problem? Literally exactly the same problem. Look at here versus look at here. Same exact reasons. Transitive property of equality, subtraction property, definition of congruence. Transitive property of equality, subtraction property, definition of congruence. Literally the exact same steps every single time. The only difference is in this one, the two angle pairs were complementary angle pairs, and here they were supplementary angle pairs, but literally exactly the same idea. So now, these are the other two that we didn't get to. I'm going to leave these for you to try on your own. These are actually the easiest ones, I think. Deceptively easy almost. Theorem number 2.4 says that all right angles are congruent. That if you know angle 1 is right angle and angle 2 is a right angle, then they're both the same as each other. There's one thing you need to remember about what right angles are. Right angles are angles that are exactly 90 degrees. That's the information I'm going to give you. You can do this proof yourself. Same thing with Theorem 2.5. If angle 1 is congruent to angle 2, angle 1 and angle 2 are supplementary, then you know that those angles each have to be 90 degrees. The one thing I will tell you with this one is this one is going to require the substitution property, since you know that the measure of angle 1 is equal to the measure of angle 2, since they're congruent. Anywhere you see angle 1, you can put angle 2 and vice versa. So what you're going to be able to basically do, I'm not going to do this whole proof out, but I will tell you that since you know that they're supplementary, that up to 180, and you're going to use a little bit of algebra, substitute, get something like this, and then you can show that the measure of angle 1 is 90 by dividing by 2. And if the measure of angle 1 is 90, then the measure of angle 2 is 90. So they must be both right angles. I will leave the actual formal proof of this up to you if you want to try it out.